Hello viewers. In this video, we will review another Edison robot project. We call it either tag game or police chase. So the agenda for this video is first we will look at the project overview, like what is this project about, what we are doing in this project. Then we will look at the prerequisites which are required by any viewer who wants to benefit from the contents of this video and want to try out these scenarios with the Edison robots. Then we'll look at the working demo of the project. We'll see how this project is going to play out and practically. And then finally, we'll do a code review to see how the code is working for the Edison robots to make it happen. So the project overview. So in this project, we are going to need two Edison robots, and they will play a game of tag. One of the Edison robot will track the black line, and it will attempt to run away. The second Edison robot will try to catch the first one on the same black line. When the first Edison robot is caught by the second one, the robots will switch the roles. So the second robot will now try to run away, and the first Edison robot will chase the second Edison robot. So they'll essentially switch places, and the cycle will repeat. That is, now the first Edison robot will reach the second one, and now the first one will start running away like before, and the second Edison robot will start chasing. So prerequisites. In order for the users to benefit from it, they should have some understanding of Edison robot, how they work, sensors, and how to load the program into Edison robot, especially using the Python programming. Infrared communication, line tracking are the features for different sensors for those robots that we are going to use. And in general, just be creative with the robots and with the different programming constructs to come up with new ideas and benefit from the different capabilities that we can unlock. So let's look at the visual of what this project is going to achieve. So we'll have these two Edison robots, so you need at least two. And this is the first robot up front, and this is the second robot here. So what will happen is the first robot will run away and the second robot will try to catch it. And when the second robot reaches the first robot, it will change its direction and start pointing the other way. Like, the kids play when they touch one another and they say, tag, you are it. So essentially that's what it is. Then the first robot will also change the direction, and it will now start changing the second robot. And now when the first robot catches the second robot, the cycle will repeat. So that's the gist of the project.
Now I'm going to turn on the robots. So the first one, which is the blue rider, is going to try to run away, and that will start in a run mode. The second robot, the one with the red rider, is going to start in a chase mode. It is the same program loaded into both of the robots. By pressing this triangle key again, I'm going to switch the mode of the second robot so that it is chasing instead of running away. Alright, and once the second robot catches up to the first robot, it will send a signal that you have been caught. It will turn around and run in the other direction. Now this becomes the runner, the second robot, and the first robot becomes the chaser. We're going to give some time for the second robot to run away, and then the first robot, after a certain wait, will turn around and start chasing the second robot. All right, so let's start the robots. So now the first robot is running away, and now I'm going to start the second robot and switch its mode by pressing the triangle key again. So it's sounding a police alarm and trying to catch the first robot. When it catches the first robot, it turns around. The second robot is now running away, the first robot is going to give some time to the second robot, and now the first robot is trying to catch the second robot. Alright, I have kept the speed a little different between the runner and the chaser, so the chaser ultimately catches the runner. So the chaser runs at a slightly faster speed, and the runner runs at a slightly slower speed. Also, there is some time I give to the runner to run up to some distance and move away. So then it has covered some distance, and it takes some time for the chaser to try to catch up to the runner. And that's how the program continues. That's the end of the program. Thank you.
Okay, viewers, we are now going to look at the Edison Robot Python program, which is executing for the two robots which are participating in this tag game / police chase. What we have here is the standard parameter initialization. Then we have the registration of 3 event handlers, which are used to change the mode of operation for the Edison robots. This is the same program which is loaded into both the Edison robot. And the reason for that is we want the Edison robot to behave both as a chaser and a runner in the same setting. So it has to be the same program, it just operates in 2 separate modes. So by default, when the Edison robots start, the mode of operation is that of a runner. When the user presses the triangle keypad, it calls the operation chase, which changes the mode of the operation for that Edison robot to that of a chaser and not a runner. So that's what the first one does. The second event handler is executed, which is got caught method. It is executed upon receiving an infrared event, which is executed on the runner robot. So the robot which is running away receives this message knowing that it has been caught. This message is sent by the chaser. So this tells the runner robot that it needs to change its mode of operation from a runner to that of a chaser, and it needs to change the direction. So this is for the runner. And the last operation, event handler, which calls the run operation, is executed for the chaser robot. The robot which is chasing gets this event when it detects an obstacle. In this case, it is the running robot which the chasing robot detects in front of it, and as a result of it, this run operation is called, which informs the chaser, hey, you're successful in catching the running robot, you need to change your direction. And that's what the chasing robot does, and it also sends this infrared data which tells the running robot, hey, you need to change your direction and your mode of operation from that of a runner to that of a chaser. And this one here changes its mode of operation from that of a chaser to that of a runner, and they both turn around in the other direction and start tracking the line in the other direction. Here we are initializing the light tracking LED for both of the robots. Again, the obstacle detection beam is off for both of the robots because both the robots start as a runner. It's up to the user to pick one as a chaser. This variable here maintains the mode of operation for the robot, and when the run chase mode is 0, meaning it is running, and when it is 1, which means the robot is in a chasing mode. This count plays an important part in the robot. We'll see over here. This is just a police siren string, and then when this string is executed for music in the robot, it sounds like it's a police. The robot is behaving like a police car and is chasing the other robot. Here we have the while true loop, which means that it executes forever. As you can see, the program will keep going on and on in cycles, where one robot chases the other, and then the other, then it turns around and the other robot changes the first. The first robot changes the other one. Here, what's really happening is there are only two parts to this while loop, and only one of them executes this part, which is if the chase move run is 0, which means um, the robot is behaving like a runner. Otherwise, this one, which means the robot is behaving like a chaser. So when it is 0 for the running robot, both of the lights are off, so it is behaving like a thief or robot who's trying to run away, or maybe stealing some money or from the bank, and the other robot is going to try to catch it. This count over here that you have, it is incremented for each execution, each loop, and when it is completely divisible by 15, which is the modulus operator or the remainder operator, it basically tells the robot to slow down a little bit, because it is stopping the robot over here and waiting for 100 milliseconds. So this little delay after 15 executions, and you can increase the number of executions like once in like 20 or once in 30, then means it's gonna run a little bit faster and take longer to be caught. Or you can reduce this number by 5 or 10, meaning that the robot will stop once in every 5 executions or one in every 10 loops, basically. So depending on how you set it, you can make the running robot run a little bit faster or slower, and this is just to help the chasing robot, enable it to catch the running robot and make the running robot run a little bit slower by introducing a delay every 15. In my case, every 15 loop. You can change it every 10 or every 5 you want to run it, make it run a little bit slower. And then this is the standard turn on white, then turn a little bit right with the speed 1, otherwise turn a little bit left with speed 1. So this is the standard line tracking, as you can see. So this robot tracks the line. If it is on white or on black, it turns a little bit left, right? Now, if it is not, the run mode is not 0, means it's 1, means this robot is now going to behave like a chaser. In this case, it plays this police siren. It looks like a police car. And this part is the same across, basically from the perspective of tracking the light. If it is on the white, but it's a little bit faster, so it drives a little bit towards the right with the speed 2. If it is if it's not on the white, it's on the black surface, then it drives a little bit left with the speed 2. So this one runs a little bit faster and it doesn't have a delay. Also, if it is going towards the right, it is turning on the right LED, turning off the left LED. If it is going towards the left, it's turning off the right LED and turning on the left LED. Kind of gives the impression of a police car with siren and flashing lights trying to track down the running thief, for example. All right, so that's for the how the robots will behave when tracking the light. But what really happens when they receive an event? Because when they receive an event, that is when they change the mode of their operation. So the first operation is chase. Chase method is, as you can see over here, it is when the keypad is pressed, then you have a chase method called. This method, what it does is basically changes the run chase mode, which is the variable defined up to 1. So it changes it from 0 to 1. So when this variable is 1, it means that the robot is now going to behave like a chaser, and this part of the while loop will execute, and the robot will make a sound like a police car with flashing lights. And also it enables the obstacle detection beam. So this helps the chasing robot to know that it has detected an obstacle. In this case, it has detected the presence of the other robot, the running robot, and it has reached the other running robot, and that's how it knows. But you cannot do it unless you turn on the obstacle detection beam. So pressing the triangle key, as I said, puts this robot into the chasing mode. Otherwise, the obstacle detection beam is off and it is in the running mode. So when the obstacle detection beam is on, now let's directly go to the run. So this run operation is basically is event is called when the chasing robot detects an obstacle, or in this case, it detects the running robot in front of it, then this operation is called, which means that this chasing robot now needs to act like a running robot, right? And it basically turns off the obstacle detection beam, sets the running mode to 0, which means now it's in a running mode and not in chasing mode. Drives a little bit backward to step away from the running robot, because the running robot has been caught. It has detected the obstacle. It sends the IR infrared data 10, which tells the running robot over here that it has been caught. And then it drives, which is a spin right, to 120 degrees. And the reason why I'm turning to 120 and not 180 degrees, which is facing the other direction, is because when I did it 180, sometimes based on where your robot is, it lands on a surface, and then when this code executes again, your robot starts facing back in the same direction. It makes a 360-degree turn instead of 120. So I have to put it a little bit towards the left side of the black line, so that when you go back into the main loop, you're not going to completely turn around, and you're on the white surface and not 180 completely, on the black surface, or facing in an awkward position. And when you work it out, you'll know with this awkward position, sometimes if you make it 180, sometimes your Edison just completely turns around and faces the same direction. So that's not a good setting. So it's some trial and error. You're able to maybe able to change this parameter a little bit. So 120 works for me, and I'm using this to change the direction of the robot. So it changes spins to 120, and then the main program will take over, and Edison will start running in back in the other direction. Now, on the other hand, because it sends this message 10, the running robot gets this message, and it reads, okay, if it is 10, then it stops driving. It plays a beep, just an indicator for myself, for the user, that yeah, it has received the message. Waits for 6 seconds. This gives a time for the running robot to run some distance before it starts changing. Otherwise, it's immediately going to chase it. So that won't be a good experience. So let the runner run a little bit. Then it sets the running chase mode is equal to 1, which means for this robot, now this code is going to execute. Yeah. So, and then it spins right. So you have not yet so far changed the direction, just like the chaser, which has become a runner. The runner is now going to become a chaser, but it has to spin right to 120 degrees, a little bit towards the left of the black line, so that when this program takes over, it doesn't completely turn back in the same direction. So you have to make it turn a little bit keep it a little bit towards the left of the black line when it turns back, so that it's able to chase down in the other direction. Don't make it 180, or you can try it and you will see the result for yourself. It will not be the experience that you're looking for. Finally, it turns on the obstacle detection beam, because this one is now a chaser, and it needs to detect it when it reaches the running robot. All right. So that is the end of the tag game / police chase Python program for the Edison robots. I hope you're able to understand this code and may be able to use this for other projects or other use cases. Thank you.